So I'm going to present my name is Uzair Hussain and I'm going to present my project on zero knowledge proof. So let's move towards the content. The content of the slides are the first and the foremost. I'm going to explain what zero knowledge proof actually is and what does it actually mean. Then I'm going to move to a really good resource to actually learn zero knowledge proof in depth with some interactive examples and a quiz which will strengthen your knowledge about zero knowledge proof, and you have a visually interactive learning experience. In the last part of this video, I will cover a real life use case scenario of zero knowledge proof, how it can be used in the authentication application which I have developed. So basically, zero knowledge proof is a way of proving that certain piece of information is true without actually uh, revealing the actual information. It's like I am saying I know a secret and I want to convince you, I want to prove it to you that I know a secret, but without actually telling you any part of that secret or the actual secret. I will somehow convince you that I know a secret. So this is how zero knowledge proof works. There are different kinds of zero knowledge proof, like uh, some interactive and non-interactive. The interactive one is like in which there's multiple rounds of proving and verification, and the non-interactive one is like a single time approver proves and the verifier verifies the proof, and that's how it is done. Let's move on to the resource that I was talking about. This is a really good resource to learn zero knowledge proof, which explains in depth what is zero knowledge proof and what are the basic components of the zero knowledge proof and how it is set up and what is the main purpose, and how it actually works. And then there are the types of zero knowledge proof explained with some visual representation that shows how zero knowledge proof with explanation with an analogy. So that can help you understand how actually zero knowledge proof works in real life, or how we can implement them in our computing systems. Let's move to a next thing, which is a zero knowledge proof game in which you have to verify if the balls are switched or not. So this is a really good game. You should definitely give it a try. The last thing I want to cover is, it's not the last thing, it's the second last thing, is the demo of that zero knowledge proof application. It's an authentication application that is using zero knowledge proof underneath. So I'm going to give you a demo in a while, but let's move on to the fourth page, which is a quiz, which will actually test your knowledge about zero knowledge proof, and it will make you feel more confident about your knowledge. So I will highly recommend you to actually go through this material, because it is a great resource for learning zero knowledge proof. Let's move along, and I will give you a demo of the authentication application, how we can actually prove to a server that we know the password instead of providing the password. You can also try it. There's step-by-step guidelines given on this page. So I will paste the link of this project as well as the authentication application in the description so you can easily use it. So as I was telling you, we are using zero knowledge proof underneath. So we are using the same concept of uh, of proving to a server that we know the password instead of providing the password. So we are providing a proof to a server, and the server is verifying if that proof is legit, if that proof is like verifiable or not. And if it is verifiable, it will let us log in. And let's move ahead, and I will show you the demo. Without actually revealing that information. It's like I am saying that I know a secret, but I want to convince you, I want to prove you that I actually know a secret, but I won't tell you the actual secret. I will convince you somehow that I know the secret. We are using the same approach, same method in our authentication application, in which we are convincing or we are proving to the server that we actually know the password, and we are not providing the actual password to the server. So by not providing the actual password to the server, we are mitigating the phishing attacks, man the middle attacks, and the privacy concerns related to passwords. Let's move ahead, and I will show you a quick demo of our project. This is our project, which looks quite similar to a normal login screen, but it is different. Uh, so basically, as every login authentication mechanism, we have to enter our username, for this case, like Uzair, and I have to submit my username, and it will provide me with the alphanumeric key, which is a challenge in this case. I will copy this challenge and create a SHA-256 hash of this challenge plus my password, which is in this case is secret pass. This is for your explanation, but we just have to concatenate these two strings. So it should look like this. And now I have to copy the output hash that's being provided. And then I have to put it in the response. And then I have to click the login button. And we are logged in. Let's try it one more time, but I will provide a same hash, but I will change some part of it. And let's try it. It says it's wrong. The response is wrong. What if I provide the actual password? It will still say wrong bit because it need a response. We need to solve this challenge to actually log in. And every time, every time I actually try to log in, the challenge will be different. So it is totally randomized. The only person who actually knows the password will be able to log in. Okay, let's try this challenge. We will just remove the previous challenge with a new one and then calculate a new hash. This is the new hash. I will copy it and paste it over here. And we are logged in. So that was the demo of our application, which is using zero knowledge proof underneath. And like there are different authentication mechanism available in the market. And recently Google has also introduced authentication mechanism known as passkeys, which is quite not quite similar, but kind of addressing the same problem. Uh, but it has its own downsides. Our authentication mechanism has its own downsides, but as I was talking about Google Passkeys, it has its own downsides, more of a device dependent type approach, and you are using your device lock to actually uh, log into all of your accounts. So that's all from our side. If you have any questions, please feel free to ask. And thank you so much.